In this movie, we look at a general strategy for solving problems about reactions. Whenever you're given an equation-based stoichiometry problem, you need to determine what is required in the question. What do you have to answer? What do you have to find out? What information the question gives to you. And very important, you must have a balanced equation. You solve the question eventually using an equation like the one that I've shown here. You rewrite the question in this format. What is question mark, how much, required unit, grams or decimeter cubed or moles or whatever is required for you to find out in the question, is equal to the given value and its unit. Then you need to multiply this by a conversion factor. And the conversion factor is the ratio in which the relevant substances react with one another, but not any old ratio in which they react. Only that ratio which is useful for answering this particular question. In other words, one which has the given unit at the bottom so that it can cancel away the given unit in the question, and the required unit at the top so that it can introduce the required unit, which is what you are asked to find out. So where do we get this ratio, this conversion factor from? And that's really the crucial part of answering equation-based stoichiometry problems. That's the only difficult part, if I could say that. It's not difficult if you know how to do it, of course, but that's the trick. And the answer is we get it from the balanced equation with probably some modification, because that balanced equation gives a particle ratio, a mole-mole ratio. The coefficients in the balanced equation, the big numbers, give the particle ratio, the mole-mole ratio. Now that's enough if both the required and given units are moles, but that's not usually the case. Usually at least one of the units, given and required, are something other than mole, and so we need to convert this mole-mole ratio into whatever is useful for this particular question. So you need to convert the mole-mole ratio into the format needed for this particular question. Required is to given. That might be a mass-mass ratio, which you find by using the molar masses from the periodic table. You multiply each molar mass by the number of moles in the mole-mole ratio for that particular substance. Or it might be a mass-volume ratio. And for such a question, it would be at STP, unless you have to use the gas laws. The mass part of that you get using the molar mass from the periodic table, and the STP volume we know is 22,4 decimeter cubed for every mole. That's only true for STP, standard temperature and pressure. It might be a volume-volume ratio. If it's a volume-volume ratio you can assume STP and you'll get the right answer, but it's much simpler if you just realize that volume-volume ratio is the same as mole-mole ratio. If mole-mole ratio is 1:2, volume ratio 1:2 as well, for example. And obviously there are many other possible required given ratios. Once you have the required given ratio in which these particular substances always react, you apply that ratio to the particular situation that you have in this question. In other words, you convert that ratio into conversion factor. Here it is. And multiply the question by that, making sure that you have the required unit at the top and obviously the relevant number as well there, not just the unit, and the given unit and the ratio number associated with it at the bottom. If all this sounds a bit abstract to you, watch some other movies where we take some concrete examples with numbers so that you can see how this is applied. Then come back and rewatch this movie.